In this question, we're given two random variables and we're given their joint probability distribution function, and we're asked initially to use this information to calculate the conditional probability distribution for y, conditioning that first x is equal to 1, then x is equal to 3. Now remember, if we want to find the conditional distribution of y, so the probability that y is equal to y given that x is equal to 1, for instance, we're just saying that for the subset where x is equal to 1, what's the probability that y is equal to 2, for instance? That for the subset where x is equal to 1, what's the probability that y is equal to 4, and so on and so forth. And we can calculate this conditional probability by finding the ratio of the joint probability, so the probability that y is equal to a particular value of y and x is equal to 1, divided by the probability that x is equal to 1. Similarly, the conditional probability that y is equal to a particular value given x is equal to 3 is equal to the joint probability divided by the probability that x is equal to 3. We're restricting ourselves only to the cases where x is equal to 3. Now, in order to calculate these, we need to know the probability that x is equal to 1 and the probability that x is equal to 3. So we need to find the marginal distribution of x before we can find the conditional distribution of y. Now, since all of these pairs of outcomes are mutually exclusive, we can use the law of total probability to tell us that the probability that x is equal to 1 is just the sum of all of the joint probabilities where x is equal to 1. So it's 0.2 plus 0.1 plus 0.3, which is equal to 0.6. And similarly, the probability that x is equal to 3 is 0.1 plus 0.1 plus 0.2, which is equal to 0.4. So using this information, we can now construct a conditional distribution. So let's start by conditioning that x is equal to 1. So the probability that y is going to be equal to 2, conditional that x is going to be equal to 1, we're going to take the probability that y is equal to 2 and x is equal to 1, so that's our 0.2, and divide it through by the probability that x is equal to 1. So it's going to be 0.2 divided by 0.6, which is equal to 1/3. Similarly, the probability that y is equal to 4, given x is equal to 3, 0.1 over 0.6, 10% of 60% of the time, y is 4 when x is 1. So our probability here is 1 over 6, or 0.1 over 0.6. Similarly, to get the conditional probability that y is equal to 6, given that x is equal to 1, we take the ratio of the probability that y is equal to 6 and x is equal to 1, 0.3, with the probability that x is equal to 1, which is 0.6, which gives us a probability equal to a half. We can do exactly the same for the conditional probability given that x is equal to 3. We divide through the joint probabilities by the marginal probabilities, and we get probabilities equal to a quarter, and a half. Now, the first thing that we might notice is that since these conditional probabilities are different, x and y must be not independent random variables, because if they were independent, the conditional probabilities would be exactly the same. So part B of the question asks us to now use this information to calculate the conditional expectation of y given that x is equal to 1, or the conditional expectation of y given x is equal to 2. Now, the conditional expectation of y given x is equal to 1, we just calculate this in exactly the same way as we do with other expectations, but instead of using the marginal probability that we're multiplying the outcomes by, we're going to use the conditional probability. So we're going to have the probability that y is equal to a particular value of y given x is equal to 1 multiplied by all of the possible outcomes. So in other words, in this example, this is a third times by 2 plus a sixth times by 4 plus a half times by 6, which is equal to 2 over 3 plus 2 over 3 plus 3, which is equal to 13 over 3. Similarly, to calculate the expected value of y given x is equal to 3, we take the sum of all of the products of the conditional probabilities with each of the outcomes of y. So this is going to be a quarter times by 2 plus a quarter times by 4 plus a half times by 6. So this is quarter times by 2 plus a quarter times by 4 plus a half times by 6, which is equal to a half plus 1 plus 3, which is equal to 4.5. The final part of this question asks us to use these two conditional expectations that we've got to calculate the expected value of y. Now remember, we're going to use the law of iterated expectations to calculate that the expected value of y is equal to the expected value over all possible values that x can take of those conditional expectations of y given x is equal to each individual particular value. Now what this means is that effectively we're going to weight each of our conditional expectations by the probability that x is equal to each particular value. So when x is equal to 1, we know that the expected value of y conditional on x being 1 is 13 over 3. We would weight that by the probability that x is equal to 1. Similarly, when x is equal to 3, we know that the expected value of y given that x is equal to 3 is 4.5. We would weight that by 0.4. So our expected value of y is going to be equal to 0.6 times by 13 over 3 plus 0.4 times by 4.5, which is equal to 4.4. You could check that by going through and calculating the expected value of y using each of the marginal probabilities. Thank you very much for watching.